Hello, everyone. So we'll get started. We work for Datadog. Datadog is world-class data platform ingesting more than 100 trillion events a day. So today, to support the story in our presentation, we're going to talk about the fictional company called Canoe. Canoe is a company, it's a website you go to when you want to go on vacation somewhere and you want to go on a dreamy vacation in somewhere sunny and so on. Any similarities with existing companies would be a pure coincidence. Please don't read any much in it.
So I'm going on to Canoe and I'm about to book my vacation and I'm looking for a really nice sunny hotel and this is the result I'm getting and kind of suddenly bats I'm afraid are gonna come out of the hotel.
Oh no, something's wrong with the recommendation engine. What happened? I didn't touch anything.
I'm not coming back to Canoe ever again.
the the job is the same as yesterday. It was working. It works on my hand. What happened? Right? And usually in your data ecosystem, right, you will have multiple organizations producing and consuming data. And within your own bubble, right, you know your own practices, you know how you produce data, you know how you schedule your job, but outside of your bubble, it's kind of not clear, it's a bit opaque. I don't know really where this data set comes from and who's producing it and how often. And it's a bit opaque, right? And so when something goes wrong somewhere in the organization, we do have a bunch of automation in place, and it does propagate. And so bad data on one end usually propagates, and before we know it, we have bad recommendations coming out of the system. And even though we didn't touch anything, well, everything is wrong, right? So we need to figure out what it is and how we got from the dreamy destination to the scary, spooky, bat-infested ones. And so how do we get there, right? Like there's a bit of like, well, I didn't touch anything, I didn't break it, and I don't know where the data is coming from, and it takes a long time to figure out what's working, right? What's not working. When everything works, it's fine. When something's not working, it takes a long time to figure out. And it's not helping that the ecosystem is very fragmented, right? Like a bunch of people are using different tools, and there's different ways to investigate, understand what they're doing, how data goes from one end to the other. And it's a little bit, if you've been traveling, it's a little bit like when you need an adapter to connect to electricity, right? Everything speaks a different language, and it would be so nice if we could unify this. So we need a common language to describe how we transform data, right? Like where the data is coming from, where it's going, who owns what, how we maintain all of this, right? So we can investigate and go through the thing end to end. And so you've seen, the problem is there's many ways to represent data transformation, lineage, and so on. That's okay. I will find the one overarching way that's going to support all the use cases and will unify everything, right? And so mandatory XKCD reference on the slides. Like before you knew it, you have another competing standard and just add it to the pile of complexity. However, what I'd like to argue is standards, the problem, if you look at these pictures of outlets, right? They all work. They all individually solve the problem. All of them provide electricity, right? The problem is not that you need an overarching spec that solve all the use case, because they all solve it. They just solve it in a slightly different way. What we need is to get together and agree on how we're going to solve this, right? So it's not something that anyone can solve by thinking really hard in one corner of the stack, right? So we need to get by starting by talking to people. And so one story I like to tell, so there's a children's book which is called Stone Soup. And the way it goes is someone shows up one day on a town square, and they start setting up like a fire, and they put a pot on top of it, and they start cooking something, right? And people come to them and say, what are you doing? Well, sir, I'm making a stone soup. And basically the story is like, if you put a stone at the bottom of a pot full of water, it doesn't give any taste, right? The idea is a stone doesn't have any flavor. And I'm saying, well, I'm making a stone soup, but if you want, you can contribute your ingredient, right? And maybe someone comes with leek, someone comes with potatoes, carrots, whatever. Like everybody bring their own ingredients, and before you know it, the soup is better for everyone, right? Like all I'm doing is creating space for people to contribute. And the more people contribute, the more it becomes useful for everyone, right? So there's kind of a nice illustration on how you build a standard in open source, right? All you need to do is create a focal point for people to collaborate and work together. And there's a great momentum to that, right? Because the more people contribute, the more the project itself becomes useful for all the people, right? Like the point of a standard is more people use it, the more it's useful because it works for a bunch of use cases, right? And you don't actually need to convince everyone. We just need to convince a few people, and there's really a network effect of the more people get convinced, the more they convince other people, and it creates momentum, right? Like you take a standard, you get it adopted by 3 people to start with, and before you know it, people were like, I don't know if it's a real thing. I don't know if I should be using it. They said like, oh, wait a minute, they're using it, I should be using it, right? And you keep, the more you build this dynamic, the more you create a thing that works. So, where am I going with this? OpenLineage. So what we're talking about is OpenLineage as standard to observe the transformations of your data. So historically, there have been 3 main ways we have been looking at how do we extract lineage from stuff. One is by analyzing source code, right? So you look at your Git repository, wherever you put your data transformation, and you do static analysis to understand how you transform data. So that works to a degree. It doesn't, that kind of approach, understand all the things that exist in your code, but it doesn't necessarily understand what's deployed or not deployed and what physical data stores it connects to. Another one is looking at activity logs. So typically you take your warehouse, you look at the query logs, you take all the SQLs in there, and you can extract lineage from it, right? And you can build a lineage of all the data sets that are in this particular data store warehouse. The problem with that approach is it loses a lot of metadata. Where the query is coming from, right? Is this something that comes from a BI tool? Is this a transformation somewhere? You lose a lot of context of what initiated the transformation, but you get a good coverage of all the data sets that are in this store. The last one is to observe the pipeline as it is running, right? It's more like an instrumentation aspect, and this is the approach that OpenLineage takes. And arguably, the argument here that it's the best way to collect metadata about something is when it is happening, right? So you could take a picture and look at, oh, I can guess what time it was taken at, and it's facing west or whatever, right? But it's so much more efficient to have the camera instrumented in capturing the GPS information and when it was taken. And so it's a bit the same idea for a data pipeline, where you can see what's happening at the time it's happening. So OpenLineage is a vendor-neutral open spec that comes with libraries for common language that help integrating with this, and it has integration with a bunch of data tools, in particular for all open source, but then also as a spec, any proprietary system can also integrate with it by building its own integration. And so before we had OpenLineage, what would happen is everybody would talk to everybody, right? Like, so it's kind of, computer science, like n-square complexity. We know it's bad, right? Like when everybody has to talk to everybody, creates a lot of duplication of effort and brittle integration. But thanks to a standard way to do it, it simplifies a lot all communication, because whenever you have a new person, a new system that wants to expose lineage, they just have to produce it according to the spec, and any consumer can just look at the spec and look at to consume it. So just we make it an big O-N problem, right? So therefore it's a lot easier. There's a lot less agreement and negotiation involved in how we make that work. And so now I'm going to pass to Harel for the rest of the conversation on how we make this work at Datadog, how we use this.
So first, to talk about how we use this at Datadog, I'll give a reminder of what Datadog does. So we talked about it earlier. Datadog is an observability company. How many events do we process a day? I forgot.
Over 100 trillions a day.
100 trillion. Okay, thank you. Thank you. I keep
That's
forgetting.
a lot.
It's just such a small number. So right now, OpenLineage powers predominantly 2 main products at Datadog. One is data jobs monitoring, which is kind of monitoring the health, the performance of your data jobs in your system. So Airflow obviously fits into this category. And the other is for data quality monitoring. So kind of monitoring the health of your data in your Snowflake, for example, or in your warehouse or wherever it sits. So to start off, what we're using OpenLineage for and how it's beneficial for us. So coming back to that reference of all those different standards, you know how you're getting together with your engineering team and you kind of want to build a new thing, and there's like a discussion about what the data model should be to power the backend, and it takes like 30 minutes to reach a consensus, and it's so easy. So instead of having to debate about this, there's already a standard out there. Why not just use it and then take it from there? So that's one main benefit that OpenLineage saved for us. And obviously, it's like we speak the same language as everyone else in the industry, which is very useful. For the other benefit, I'll kind of need to go a bit deeper into the spec, and then we can talk about it. So let's talk about the details of the OpenLineage spec. So we have three main concepts as part of the spec. A job, which is basically a thing that runs. Then a job run, which is an instance of the thing as it's running. And the notion of a data set. So a job run can consume a data set or produce a data set. Now, those are very extensible. And they're extensible in one way, in a centralized way, and also in a way that is kind of more decentralized and allows for a lot of customizations. And we call this facets. So for example, let's say I have an Airflow job, which is a DAG, and I have a task. And so that task may have a very detailed facet that contains information that's useful for someone who's trying to debug an Airflow task, for example. And so in our ingestion pipeline, when we read in OpenLineage metadata, then basically we kind of look at, okay, so it's an Airflow job, so I know to expect this run facet. And then in our processing logic, we kind of leverage that. So it allows us to, on one hand, to kind of process everything that comes out of the box from all the different integrations that are supported with OpenLineage metadata, but also it allows us to add our own customization on top of it. So when we generate our own internal metadata from the things that we observe, we kind of package it into OpenLineage format to make it standardized. Another concept is, the concept of kind of a transition event. So the way that OpenLineage works is, a job starts, so you get like a state change. So a job starts, and then it starts running. So as it runs, maybe there's metadata. So think of a streaming job that might have to report, check marks of a Flink job or things like that. And then there are a few terminal states, like a complete event, or maybe the job was aborted or failed for some reason. So let's take a few examples and kind of see what it looks like, and then how we use it in the product at Datadog. So what I'm looking at here is a complete event for an Airflow task. Let's focus on the job part of the event here. So here in this job, I can see daily sales ETL. There's a description for it. And just using this very basic metadata that gets reported in OpenLineage format, I can already start to populate this dashboard where I can see, okay, so here are all the job runs, maybe the run duration. I can track that. I can go into individual runs. Now, let's look up a little bit. So here's a job run, right? So this is an instance of this task that's run. And now I can use it to populate even more metadata. And the thing that we do at Datadog is also combine this OpenLineage metadata with other platforms, right? And with other sources of telemetry. So in this case, we're also pulling in task logs and correlating them with this Airflow task run. So we can see kind of in one place, okay, so this job failed, and I can click on this failed task, and I can maybe bubble up immediately, oh, wait, this is the thing caused this task to fail, and maybe use Bits, our friendly neighborhood AI agent, to help you solve the issue. Actually, we tested this. This is like obviously an example DAG for demonstration, and our AI agent told us, well, you kind of coded this task to fail every 4 times, which was kind of silly, but true. So moving on with the spec and kind of what you can see here, you also can see inputs and outputs. So in this case, I can see the input to this task is a table. I can see the fields. And the output, I can also see some statistics. So this task also emitted 2,500 rows. And this is how many bytes. And I can also emit like histogram details of like for specific columns, what are the max, min, and so on. And so using this metadata, it's all kind of built on correlations, right? So a job is something we observe, as Julien talked about earlier. So we observe the job emits telemetry, and then on the back end, you kind of have to stitch it all together and correlate it together, right? So you need to make sure that the name of the thing that you emit then maps to the next name of the thing, and it's a lot of very tedious work, which is why doing it in open source is very beneficial, because everyone kind of puts in their own vegetable into the soup, and you have really good coverage. But then also, in some cases, we won't have coverage from OpenLineage, so we'll augment it with our own sources of telemetry. So then what we can do is start stitching together these beautiful lineage graphs, so you can see how everything in your system comes together, and how your Snowflake tables then feed into a dbt model that's maybe even kicked off by an Airflow task, and then consumed by another table. And when there's an anomaly or an issue with something that could be detected, let's say we have like a data quality anomaly detection for freshness, then I can hop into this view and kind of in this cockpit see, oh wait, there's an issue, where did it come from? Go upstream and find the root cause. Another cool concept that has been very useful for us is the concept of a parent run ID. So even within Airflow, there's the concept of DAG and task, which are both, from the OpenLineage perspective, they're both kind of job runs, but then there is a relationship between them with a parent run ID. But as we mentioned earlier, the data ecosystem is quite complex. So we can also use that to represent cases where an Airflow DAG or an Airflow task will kick off a Spark application and the Spark job in it. So here in this example, you can see at the top, the long green line is the Airflow DAG, and then you can see a task underneath it, and then you can see all the different colors or different Spark jobs and different Spark applications that are running and getting kicked off by that Airflow DAG. And kind of the way we can stitch this all together is a combination of OpenLineage parent IDs that get propagated from the Airflow task into the Spark job. And for Datadog specifically, because we also have our kind of agent that runs alongside the Spark jobs, we also correlate it with trace ID, so we can do even deeper dive into your Spark job to get more performance telemetry. So kind of trying to summarize this, there's a lot of things you can do with this type of metadata. And really the possibilities are quite endless. And now,
hey, look, we fixed it. Thanks to the lineage, we were able to find the root cause of the problem, fix the bad job that was getting that bad third-party data, like they changed the delimiters on their CSV files for some reason, and we fixed it. And now we get back to the sunny recommendations for our users, and they're happy and using it, right?
I am happy to come back to Canoe to search for my travel.
Canoe, your best destination.
Now we need to play that meme, like the holiday thing.
I don't know that meme, but we can do something.
Maybe someone got the reference. Cool. So kind of summarize it. How can OpenLineage benefit you? If you want to get started, it's open source. Go ahead and try it. Identify the key data sets, the key jobs that you want to instrument in your system, and start instrumenting them with OpenLineage. All of these are supported in open source. And then profit, or at least know that your data isn't completely messed up.